Lesson 2.6 is the graph of y equals k over x and y equals k over x squared, or k divided by x squared. And we know this as the inverse variation. So we go back to lesson 2.2, and this is the inverse variation. So we're going to graph these. So the graph of y equals k divided by x. Let's talk about that first. The graph of every function with an equation of the form y equals k over x, where k does not equal 0, is a hyperbola. And I'm going to show you what a hyperbola looks like with this example. So in example 1, what is the domain and range of the function with the equation y equals k divided by x? And then let me slide this down a little bit so you can see these graphs. Okay, so we were on example 1. See these graphs here? I have my arrow pointing at them. Those are hyperbolas. They're kind of like partial parabolas. They're like hyperparabolas, if you want to think about that. They only do parts of them, or little bits and pieces, so they're not complete parabolas. They're like, if you join the two on each graph, you'd have probably a complete parabola, but it's like parts of it. So if you notice these hyperbolas, these graphs, one thing you want to notice is they never touch the x-axis or the y-axis. They get really close to them, but they never touch them on either of these. So let's talk about the domain. We're going to do the one y equals k divided by x for either one, actually. The domain, which we know as those x values, x such that on this, notice it's everything except 0. X is never equal to 0 because it never touches it. So the domain is x such that x does not equal 0. And the range, which is those y values, it's the same thing. It never touches y, so y such that y does not equal 0. That's the domain and the range of this equation y equals k over x. The family of graphs of y equals k over x share another property. Each hyperbola in this family consists of two separate parts called branches. When k is greater than 0, the branches lie in quadrants 1 and 3. If k is less than 0, the branches lie in quadrants 2 and 4. So let's look at that. So if k is greater than 0, which is this graph on the left, or in other words, we're dividing x by k, which is greater than 0, so it's a positive number, then you have a graph in quadrant 1 and quadrant 3. But if you divide x by, or if y equals k divided by x, and k is less than 0, so it's a negative number, then your graphs, your branches of this hyperbola, move to quadrants 2 and 4. So that's the difference. These graphs also have a vertical asymptote. And that's kind of a funny spelled word. A-S-Y-M-P-T-O-T-E at x equals 0. So vertical, we know that's up and down. It's a vertical asymptote at x equals 0. So when x equals 0, which was right at the center, that line x equals 0, which is actually the y-axis, is called a vertical asymptote because these graphs never touch those lines. So a graph will get closer and closer and closer to something but never touch it. That's called an asymptote. And then there's a horizontal asymptote at y equals 0. So when y equals 0, which is right the horizontal axis, which is the x-axis, that's when y equals 0. Y is not a number higher or lower, it's just 0. Then you have the graphs not quite touching them, so there's an asymptote there as well. Okay, now let's talk about the graph of y equals k divided by x squared. So not k divided by x, but k divided by x squared. Let's talk about that graph. So from the video about how to graph in the calculator, which you should know how to do, we can come up with some graphs. So in example 2a, I want you to do this in your calculator while I'm going through it on the screen as well. So graph y equals 24 divided by x squared in a window with x such that x is greater than or equal to -5 and less than or equal to 5. So in other words, your minimum and maximum x values are -5 and 5. And for your y values, it's -10 and 10. So y such that y is greater than or equal to negative 10 and less than or equal to 10. Sketch the graph below, then clear the screen and graph y equals negative 24 over x squared. Okay, so on the left side, we're going to call this y equals 24 over x squared. And on the right graph, it's going to be y equals negative 24 over x squared. Let's do the left one first, the y equals 24 over x squared. So I'm going to sit and draw what it would look like, but make sure you can graph it in your calculator and see this as well. So I'm going to go from negative 5 to 5 on my x-axis and negative 10 to 10 on my y-axis. And that's what your graph should look like. So your graph is in quadrant 1 and 2. And there's nothing in 3 and nothing in 4. So these are two branches. They are not a hyperbola now. They're just two branches, and they're called an inverse square curve. Inverse square curve. So for the graph on the right, y equals negative 24 over x squared, it should look like this if you graph it in your calculator. And next we went from negative 5 to 5, and for y we went from negative 10 to 10, and you should have graphs this time in the third quadrant and the fourth quadrant that should look something like that. Okay, let's talk about the domain and range for these graphs. So the domain for every inverse square function or inverse square curve is, let's see the domain, I'm going to write it up here, x such that x does not equal 0. Because once again, these graphs aren't touching that x equals 0 line. Now the range depends on the k value. When k is positive, so if k is greater than 0, then the range is y such that y is greater than 0. But if k is negative, so k is less than 0, then the range is y such that y is less than 0. So that's a little bit easier to remember. If k is greater than 0 or it's positive, then the range is going to be positive, and that's what you see on this left graph. That's when k is greater than 0. And on the right graph, if k is less than 0, then your range is going to be less than 0 as well. So all the information or all the graphings will be in the third and fourth quadrants below, like negative y values. Okay, let's do another example, and I want you to also graph this in your calculator as I'm drawing it on the screen, so you can do this as well. So we're going to graph y equals 36 over x squared, and this time we're going to do x greater than or equal to negative 6 and less than or equal to 6, and y greater than or equal to negative 10 and less than or equal to 10. That's going to be the left graph, so y equals 36 over x squared. And the right graph is going to be y equals negative 36 over x squared. So in this case, k is less than 0 on the right graph, and the left graph, k is greater than 0. Because it's positive 36 on the left graph and negative 36 on the right graph. Okay, so let me draw the left graph. You have the y-axis and the x-axis, and we are going from negative 6 to positive 6 for the x values, and negative 10 to positive 10. And your graph should look something like this when you graph it in your calculator. So in this case, it's going to be in the first and second quadrants because k is greater than 0. K is positive. And your domain and range for this is x such that x cannot equal 0 because it's not touching 0. And your range, y such that y is greater than 0 because k is greater than 0. And that's all for that graph. For the graph on the right, that is y equals negative 36 divided by x squared, so your k is less than 0. So let's draw that here. Make sure you can graph it on your calculator. And we went from negative 6 to positive 6, negative 10 to positive 10, and it should look like this. So your graph is in the third and fourth quadrants this time. And in this case, the domain is x such that x is not equal to 0, because it's all the values except 0. And the range is y such that y is less than 0. That's because k is less than 0. K is a negative number. Notice that the graphs of y equals k divided by x and y equals k divided by x squared have the same vertical and horizontal asymptotes. And we talked about asymptotes previous. It's the graph of the line that gets closer and closer and closer to something, but it never quite touches it. And in this case, we said the asymptotes are at the vertical one is at x equals 0, and the horizontal is at y equals 0.